I am Sajjita, and I study how cells understand its environment. Imagine yourself in an airport that you have never been to before, and you suddenly smell this delicious aroma of coffee coming from a distance. Although you do not know the layout of the airport, you will still be able to find the source of the smell because the smell guides you. And every time you take a correct step, the smell gets stronger and stronger, and that in turn helps you to take the next step towards the right direction. This progression from a faint smell to a strong smell can be called a gradient, and the process of decoding this gradient can be called gradient detection. If there is a big difference in the strength of the smell with every step that you take, then the gradient is strong and it is easy to follow. But if there is a small difference with every step, then the gradient is shallow and it is harder to follow. Gradient detection is a very fundamental process, and it is crucial for our development and has many other essential functions. For example, if you have an injury in your hand, the immune cells in your body would know how to get to the site of the wound and repair it, thanks to their ability to perform gradient detection. But for cells, it can be a difficult task if there are many gradients all at once, and it becomes even harder if they are shallow in nature. It's somewhat similar when you smell coffee from multiple directions and you have to make a decision which way to go to. For cells, we currently do not have a very clear understanding how they navigate through this complex gradient so precisely, and that's what I'm trying to understand in my project. For this, we use yeast cells. Yeast cells have two opposite sexes, and they secrete pheromones to attract each other for mating. These secreted pheromones create shallow gradients. In natural situation in a population, each cell has multiple potential partners, but they choose only one cell to mate with, meaning they have this ability to orient towards one gradient even though there are many gradients around them. But it is difficult to track one cell's activity in a population, and that's why we have come up with this idea to create artificial gradients where we control all the parameters. For example, the location of the gradient or the distance of the gradient from the cells, timing, and also the number of the gradients. Starting simple, we gradually recreate the complexity of the natural situation and observe selectivity. From this, we not only understand how pheromone guidance arrange yeast mating, but also we learn how cells in general decode complex landscape of shallow gradients.